Okay, now we have a kind of a hypothetical situation. A physics student finds herself in the middle of a frozen pond, and unfortunately the pond has no coefficient of friction at all, so she can't go anywhere. Okay, so she's stranded. So what's she going to do? Well, why not throw textbooks in one direction so that, according to Newton's third law, she will then go in the opposite direction with some kind of velocity. Our job is to figure out what velocity she would actually go at. Let's assume she can throw the books at about 8.0 meters per second this way. Again, according to Newton's third law, she applies a force in this direction. An equal and opposite force should be applied in this direction. Now, she has a weight of 730 newtons. We need to divide that by 9.8 in order to get her into kilograms, which would be 74.5 kilograms. Okay, we can solve this using acceleration, but I do think it's still easier using momentum. Let's remind ourselves that we do have an inelastic collision, m1v1 plus m2v2 is equal to m1 plus m2 multiplied by velocity. Now this is a typical equation for inelastic collisions. However, this one's a little different because the books are with her already, and she is going to cause them to separate from her as she throws at 8 meters per second this way. So we really need to invert this equation here. So we have m1 plus m2 multiplied by velocity is equal to m1v1 plus m2v2. Okay, so let's start off. Let's let m1 be the books and m2 be the mass of the girl. So we'll do 1.2 plus 74.5. Okay, it's logical to think they're not traveling initially, so we'll write that as 0. Equals 1.2 times a negative 8.0, as the books are going west or to the left. Okay, plus 74.5 multiplied by the unknown velocity v2. Okay, now velocity v2 not going to be very large. It was going to be 0.13 meters per second. Now that's expected because her mass is much larger than the books. Well, not stranded any longer, but will take a while to probably go in this direction in order to be safe.